myself Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I am discussing about the reciprocity theorem. That is, first of all, what is the statement of reciprocity theorem? In the given circuit, it states that the circuit consists of only single source, either voltage source or current source. Then the ratio of excitation to response is same when the positions of excitation and response are interchanged. That means excitation means the source value, response means our finding value, either current passing through element or voltage across the element. That is, I am showing you, for example, the given network. This is suppose given network. For that network, we are giving the voltage source, only having single source. Then suppose this is the branch connected to circuit, then you have to find out response is current passing through resistance R. That is, we have to find out the response current passing through R with respect to the voltage source V. Again, this is the first case. Again, in second case, both current branch and voltage branch are interchanged. That is, that voltage branch is interchanged with current element, and where current is passing, that interchanged with voltage source with same directions, with the same signs. There is no interchange of signs also. Then and also there is no interchange of elements also. Do not change the positions of resistances elements are in the given circuit. Only change the positions of current value branch and voltage branch. Then in the second case also, we have to find out the current I passing through the branch with respect to the voltage source V. Suppose in the first case it is taken as I1, in second case it is taken as I2, then in both cases we can obtain both currents are equal, I1 equal to I2. Then this condition is satisfied. What is that meaning here? The ratio of excitation to response is same. Why? Because in both cases excitation is same. That is, voltage source is same. That's why the ratio is as usually same. After finding equal current, both currents are equal in both cases. Hence, reciprocity theorem can be verified for the given circuit. Not only given voltage source current branch finding. In some circuits also, that is, in place of voltage source, current source also given. For example, in the given network. Then we have to find out voltage across the element also. That is, we have to find out the voltage Vx with respect to the current source value. And also both are interchanged. In both cases also the value of voltage Vx is same. Hence, the reciprocity theorem can be verified. Here our aim is not only voltage source, any source, current source is given, then voltage will be find out. Voltage source is given, then current will be find out. Only single source circuit. We cannot find out reciprocity theorem for circuit having two sources. In the given problem, in the examinations, suppose the circuit is given having two sources, then you can simplify only one source by applying source transformation technique. Eliminate that. Or if a circuit consists of two sources, then it is not possible to find out reciprocity theorem. Reciprocity theorem can be applicable to only single source networks only. Okay, then you can verify the reciprocity theorem by taking simple example here. The example problem is verify reciprocity theorem. In the circuit, only one voltage source, 5 volts, is given. What is our aim? To find out the current passing through 4 ohms. Okay? Then, hence, here I am applying KCL, KVL, that is I1. You can take current directions in any direction, either clockwise direction, either anti-clockwise direction. Then apply KVL here for each loop. Okay, that is KVL for first loop. Apply KVL to first loop, that is loop 1. Okay, here what are the elements here? We have the given circuit, that is in the given circuit we have three elements are there, that is 2 plus 3 plus 4. The current passing is I1, and also 3 ohms is mutual element which is belong to first loop and second loop. Both currents are in reverse direction. Then the drop is minus 3 into I2. Again 4 ohms also is a mutual element between 1 and 3 loops. Then the drop is minus 4 into I3. Then the voltage source value is 5 volts, then equal to 5. The current passing from minus to plus, lower potential to higher potential, then voltage source value taken as positive. Then you can simplify the equation here. 2 plus 3 5, 5 plus 4, that is 9I1 minus 3I2 minus 4I3 equal to 5. This is the first loop equation. In the similar manner, we can apply KVL to second loop as well as third loop also. Okay. What is the second loop equation here? Minus 3 is the mutual element, that is minus 3I1, plus what is second loop resistance value? 3, 2, 3. That is 6 plus 2, 8I2, and there is no third element, that's why equal to 0. Then it is loop 2 equation. Then similarly, what is loop 3 equation? Minus 4I1 plus there is no I2 branch between second loop and third loop. Then 4 plus 4, 8I3 equal to 0. There is no voltage source in the loop also. That is taken as equation 3. Then you can solve equation 1, 2, 3. Then we will get the loop currents values are, that is I1 equal to 0.85 ohm, 85 amperes. I2 equal to 0.32 amperes. Then our required value is I, that I is I3 equal to 0.43 ampere. Okay. We have to verify this value in second case. What is the second case? Current source, current branch value and voltage source both are interchanged here. Then I am showing you how to both elements are interchanged here. Okay, this is the given circuit. Then this is the voltage source 5 volts, and this is the current branch I. Okay. Then the 5 volt source is replaced with current branch, and that current branch is replaced with voltage source. Then here this is taken as current I, and this is connected plus minus which is taken as 5 volt. Okay, in this way, you can interchange the current branch as well as voltage source branches value. Okay, do not interchange elements, only change current branch as well as voltage source values. Okay, then again in the circuit, again you can find out loop analysis. That is, we can apply mesh analysis. That is, I1, I2, I3 here. Then apply same equation we will get here, that is 2 plus 3, 5 plus 4, 9. What are the equations? Apply KVL to each loop, that is 9I1, the 3 ohms is mutual element minus 3I2, again 4 is also mutual, there is no source, voltage source in the first loop, then equal to 0. Similarly, second loop equation also 2 plus 8, 2 plus 3 plus 3, that is 8. There is no element between second loop and third loop, that is 8I2 equal to 0. Then 0 I3. There is no element between second loop and third loop. And also here minus 4I1 for third loop equation, and there is no loop current value I2. Then 4 plus 4 8 I3 equal to 0. This is third equation. Already we know how to write down the KVL equation. Okay, in each loop. 9 is the total resistance in first loop, and also 3 ohms is mutual belong to the second loop, and 4 ohms also mutual belong to third loop. Then I1 I2 in reverse direction, that is taken as minus 3 I2. I1 I3 also reverse direction, that's why taken as the drop is minus 4 I3. Okay, you can solving equation 1 2 3, then you will get the values of I1 is 0.43 ampere, that is our required current I value. Similarly, I2 value is 0.16 ampere, I3 value is 0.84 ampere. Then in both cases, observe the current value with respect to the given source voltage value. Here, after interchanging, the current branch value is 0.43 ampere, and also before interchanging, the current branch value also 0.43 value, 0.43 ampere. That's why in both cases, from the single voltage source, before interchanging and after interchanging, the current value is same. That's why the ratio of excitation to response is also same. Hence, the condition is satisfied. Then how to write? Hence, reciprocity theorem. Reciprocity theorem can be verified or is verified. Reciprocity theorem is verified. Why? Because in both cases, the current passing through branches is before interchanges and after interchanging, the current is same. Okay, in this way, you can verify reciprocity theorem for the given electrical circuits. Please subscribe our channel and share to your friends.